introduction slide. So the main agenda, the main problem we are trying to solve is, so in today's world, there are some AI systems which are able to give the floor plan presentations based on the rough sketch if we provide it. But the problem we are trying to solve is, when user comes with the requirements to us, we'll try to take his requirements. And if you look in India, everyone constructing a house will definitely include something called as Vastu principles inside their the structure which they are building. So these Vastu principles enables to while you are constructing the house will have certain advantages. So we definitely need to include those advantages while generating a floor plan. That's exactly we are trying to solve. So what we'll be doing is, we'll take the requirements. Once we get the requirements, we'll try to find the best possible principles that will align for those user requirements, and then we'll be sending these user requirements along with the principles to the model for generating the output. Can you move to the next slide? So the problem statement is, as I've said, in the present world, if an architect has to generate floor plans according to the user requirements, if the user doesn't like the plan generated, then the entire work which he has put in will be wasted. So what we are trying to solve is, we try to provide them with an assistant. So these floor plans can be generated in a minimum amount of time. So they can get some confirmations with the clients, and if they are okay with certain floor plans, or if they need any customizations, our AI platform can do that customization for them. So that will going to save a lot of time for those architects. Can you move to the next slide? So the models which we are trying to use is a stable diffusion model, which is a text to image model. So we'll be giving the user requirements as input, we'll be getting floor plan as output, and we are trying to integrate something called as SHAP. So this what does this SHAP does is, okay, whatever the output that is generated by AI in the present world, the user does not know what has actually influenced that output. Now we are trying to integrate a SHAP algorithm to it. So this SHAP can analyze what are the factors that have actually influenced the model to generate such kind of output. So we are using Python as our programming environment for developing this platform. Can you move to the next slide? So our objectives are integrating the SHAP algorithm to stable diffusion, and fine-tuning our stable diffusion model for a specific domain, and then provide the user with the relevant architectural principles for why the plan is generated in a certain way. Next slide. So coming to the existing systems, as I've said, the traditional architectural designs relies heavily on the manual planning. So the user has to generate, use certain software like CAD, has to and generate the plan on their own with their own efforts. So that's gonna take him a lot of time. So if and there are certain systems which are gonna take the rough sketch as an input and will be going to give the detailed floor plan as an output. But that's where you also require help of an architect who can give you with the rough sketch. That's we want to eliminate. Can you move to the next slide? So our proposal system is, we want to use some technique called as few shot learning and explainable AI, where we'll be training the fine stable diffusion model with a data set of images. So that stable diffusion model can understand how a floor plan will be generated and all. And we also try to integrate the explainable AI algorithm, so that we can interpret the output which is produced by the stable diffusion. So in the next slide, we can see the dataset sample that we are using to train our model. So we'll be having a floor plan, and for the corresponding floor plan, we'll be having a description of what that floor plan is. So this description actually contains all the principles this particular floor plan follows. Can you, for example, the architectural principles contain something like this 8 columns, like what is the plot size and what is the house facing direction, and what are the different dimensions of the house and all. Like all the Vastu principles will also be included. In the next slide, I'll show you what are the sample Vastu principles that we have. So for different plot sizes, we'll be having different architectural principles. So we'll be preparing a data set in advance, so that when a user gives us requirements, for that user requirements from this database, we'll be identifying the relevant principles. So can you move to the next slide, please? In this, I'll explain you the entire flow of how output will be produced. So when a user will be giving an input, that input will be given to stable diffusion model. This stable diffusion model is already trained on the dataset which I have shown you earlier. So once the stable diffusion model takes that input, that will understand, okay, what are all the user requirements and according to those user requirements, it will be generating an output. So these are the user inputs that will be taking. In the next slide, you can see the output that is produced by the stable diffusion model. Can you move to the next slide, please? This is the output that will be generated by the model. So now we'll be getting the sharp values. Explaining like what are the different terms in the prompt that actually influence this particular output. Next slide, please. Can you move to the next slide, please? So in conclusion, our platform streamlines the architectural design process by generating the house layouts within a small period of time. And it also cut down both the time and the cost for the architects and the real estate developers. So that's exactly, and in the future we are trying to include something called as control net, where we'll be having a complete control over how a floor plan is generated. So we can have the control over the logical structure of the floor plan that will help us control different aspects of the floor plan that is going to be generated by the model. Yeah, that's the presentation. If any questions, I'm happy to answer.
Any question, please? No questions. Can you hear me?
Yeah, I can hear.
Okay. Thank you for your presentation. It's a clear topic, interesting topic as well, despite I'm not engineering background, but I can clearly get the message from your article or presentation. Can you please summarize the main contribution in few sentences that your paper added to the body of knowledge in your area?
So the main contribution is the explanation part, explainable AI integration. So the current AI systems does not have the ability to show what actually influenced to produce a certain output. We are integrating sharp algorithm so that the sharp interprets why a certain design has been produced by the model. That's the main thing. And second thing is we are integrating something, we are doing something called as few shot learning, where the model, and we are trying to integrate something called as control net, where we'll be having a logical control of why a floor plan is generated in a certain way, along with the along with providing the user with the explanation of the Vastu principles that are actually used in the floor plan. I want to ask you a question, do you have any knowledge of Vastu principles?
Again, please, do we have what?
Vastu principles. It is something that will be followed while constructing a house in India. I think in foreign countries that might not be followed, but when you come to India, that must be practiced while constructing a floor plan. So that's the value addition that we are providing with our work.
Okay, thank you very much. Now I move to the fifth